Good afternoon. We are looking in this video at work problems. This by no means is the physics definition of work. We are talking about algebra work problems. We have here a representation of what a formula you could use for these type of questions. X over A plus X over B equals 1. This just represents two items or two entities doing the work. It could have been a number of them, but they would always equal to 1. Let's focus here on what A and B are. A represents the time for A. A and B, these items can be either people or objects. A in the denominator here represents the time needed for this object or person to complete a task alone. B represents the time needed for object or person B to complete that task alone. X is what you're solving for, the time needed to do the task together. You might be familiar with these type of work problems. In all instances, the time needed for a bunch of people to do a job is always less than the time needed for individual person to do the job, because more people can do the same job quicker than a single person doing that same job. X is always less than A, X is always less than B. X over A represents the fraction of work contributed by person or object A, and X over B represents that same fraction of the contribution done by object or person B. All of this might seemingly appear overwhelming, but trust me, it isn't. All of these fractions must always equal a whole, and that whole is always 1. When we look at a word problem over here, you'll know exactly how all of this plays out. You have to keep yourself cognizant of this expression, X over A plus X over B equals 1. It can also be written and sometimes presented in the following way. 1 over A plus 1 over B is equal to 1 over X, where A, B, and X represent exactly what you see. I prefer this expression form versus that, and I'll tell you why when I do question 1. This right here is a more meaningful way of expressing these work problem formulas. Let's look here at the first question of this video. We have a person working alone, a person or an object. If working alone, A does a job in 10 hours. B would do that same job, but it would take 12 hours. How long would it take if both of them were working together to do that same job? How long would that job take? And that's exactly why these are called work problems. What do we see over here? A takes 10 hours, B takes 12 hours. Of course, when you're working together, it'll take a figure less than that, which is why I always said X is less than A and X is less than B. Alright, this represents the time needed for A and the time needed for B. Simple as that. And I've given you the formula. It's X over A plus X over B is equal to 1. All you gotta do is plug things in and solve for X. I have X over 10, the job or the fraction of the work contributed by person A, plus X over 12, the amount of contribution done by person B, is equal to 1. You can do a common denominator, 10 and 12, 60. They both go in there. 6x, 12 goes in 65 times, 5x is equal to 1. You'll have 11x is equal to 60, and then x is equal to, we can present a decimal answer, 60 divided by 11, 5.45 hours. And that right there is exactly what I'm talking about. Working together, the job is done much faster than when you're working separately. And 5.45 is less than 10 and it's less than 12. Now what does this mean, and why does this expression seem better than the other expression I was alluding to earlier? Because if you were to put 5.45 in places of X, you're looking at 5.45 over 10. This is the contribution done by person A. If you did 5.45 divided by 10, which is the number of hours that person A takes or object A doing it alone, and you multiply it by 100, you get a percentage of the contribution of person A to that whole job. If you did 5.45, which is X divided by 12, this is the contribution done by person B. These both contributions in terms of percentages should equal to 1 or 100. 100% is 1. So think about it in this way. 5.45 divided by 10 is the amount of work done by person A towards that total job. 5.45 divided by 12 is the amount of work or the contribution done by person B towards that total job. But what is your answer to this question? Is this right here, 5.45. It would take them 5.45 hours to complete that same job, which they could do independently in 10 or 12 hours. This second and last question of this video is a meaningful question, and it has a slight twist in it, but it's not hard. We have some machines over here that can fill a swimming pool independently in a given amount of time. We also have a machine that if you wanted to drain out or empty out your swimming pool, it can do that. We have machine A, which can pump water and fill a swimming pool in 15 hours. It would take machine A 15 hours to fully fill that swimming pool with water. Machine B could do the same job filling the swimming pool with water, but it would take 20 hours to complete that task. And there's a certain machine C, if you want to empty out or drain out your swimming pool, it can drain out your swimming pool, but it would take 25 hours to empty out. We have two machines that have the task of filling a swimming pool, and we have one machine which has the task of draining out a swimming pool. How long would it take to fill the swimming pool if all machines are running at the same time? In this instance, you have two machines which are operating and filling in the swimming pool, and then there's one machine which is counteracting that and draining it out. So therefore, you would have an expression which would look something like this, all of it equal to 1. This right here is machine A, it can do the task in 15 hours. This here is machine B, it can do the same task in 20 hours. Since they're filling the water, you put a plus over here. Then you have machine C, which is emptying out the swimming pool. Since it's counteracting, you have to put a minus, and it can do that in 25 hours. You have to just do simple algebra here, a common denominator here of 30, a common denominator here of 300. 15 goes in 300 20 times, 20x, 20 goes in 300 15 times, 15x, and 25 goes in 300 12 times, minus 12x. All of this is equal to 1. Do the simple algebra, 20 plus 15 minus 12. You have 23, x is equal to 300, and x is equal to 300 divided by 12, and that'll give you exactly how long it would take, and it would be 13.04 hours. 13.04 hours for two machines which are relatively efficient in filling the swimming pool and working against this third machine which is constantly emptying it out. But it's always emptying it out at such a low rate that it just takes 13 hours to fill that swimming pool, with water, two machines filling in and one machine draining it out, and that right there, your answer should be good. With that, I tell you, remember this equation form, x over a plus x over b is equal to 1, and these pluses and minuses can change with regards to whether you're doing a task or whether you're counteracting a task. Keep that in mind. Thank you for watching. Have a nice day.